So students, welcome back once again. We have covered two topics till now, that is Bernoulli distribution as well as binomial distribution. We come one step further from it and we arrive at Poisson distribution, or some say it Poisson distribution. Any which way, that is the distribution which we are studying right now. Now, Simon Denis Poisson was the one who discovered this Poisson distribution. Let me tell you some interesting facts about this Poisson distribution. Firstly, unlike Bernoulli and binomial, even this one is a discrete probability distribution. If you remember watching the very first introductory video of theoretical distribution. Anyways, moving one step further now. Poisson distribution or Poisson distribution is uniparametric. That means it has only one parameter. That is nothing but it has only one parameter, and that parameter is called lambda. This is called as lambda. It's a Greek alphabet. So it is uniparametric. That means it has only one parameter called as lambda. So now, as usual, if there is one parameter, that means even there will be a mean for it, and the mean is also lambda. Same way, there is something called as variance. Interestingly, in Poisson distribution, the mean and the variance is the same. That means if mean is lambda, even variance is also lambda. Next is the standard deviation. Standard deviation is nothing but square root of variance, that is square root lambda. So students, Poisson distribution is uniparametric. That means it has only one parameter, which is lambda. Mean and variance both are lambda. Standard deviation is square root of lambda. Now, as I told you earlier, Poisson distribution is a limiting form of binomial distribution, is a limiting form of binomial distribution. If you remember, I told you in the previous video that binomial distribution tends to Poisson distribution based on two things, and that is what which is here also. Poisson distribution is a limiting form of binomial distribution. How is it? Because whenever n tends to infinity or becomes more and more, and p becomes smaller and smaller, that is tends to 0, we get Poisson distribution, and that is why the mean or lambda which is derived is nothing but n into p. So what is lambda mean? Mean is nothing but it is the limiting form. Poisson distribution is the limiting form of binomial distribution. Binomial distributions mean n into p. When we multiply, we get the mean of Poisson distribution. Remember another thing about Poisson distribution, that is nothing but the PMF. The probability mass function for Poisson distribution is nothing but, again, we have to write it P of x is equal to x equals to P of x is equal to, what's the formula now? The formula for Poisson distribution is e to the power minus lambda into lambda to the power x divided by x factorial, comma, don't forget to write the range. Understand students, it is very easy to remember the range. In binomial distribution, we said that the range is nothing but a finite series, x is equal to 0, 1, 2 up to n. But here very clearly we are telling that n tends to infinity. That means the data of n can be large. That means the range is nothing but x is equal to, I will write it down here, range is nothing but x is equal to 0, 1, 2 up to infinity. The reason is because n tends to infinity, and that is why the range of a Poisson distribution is also x is equal to 0, 1, 2 up to infinity. Don't worry students about this part, that is e to the power minus lambda. Hope you all know how to find it out. You have to refer to your Poisson distribution table in your statistical tables. You have to refer to that tables, and that is how we derive the values. We will look into it more when we do the problems of Poisson distribution. As of now, understand about Poisson distribution. To brief you once again, it is a uniparametric distribution, mean is lambda, variance is lambda, standard deviation is square root lambda, it is a limiting form of binomial distribution, and lambda is nothing but n into p. PMF is p of x is equal to e to the power minus lambda, lambda to the power x by x factorial. Range goes on from x is equal to 0, 1, 2 up to infinity. And remember the last thing here, that is, when does Poisson distribution tend to normal distribution? When does a discrete distribution like Poisson tend towards normal distribution? When is it? Only in the case when n tends to infinity. When n tends towards infinity, Poisson distribution tends to normal distribution. Students, remember this. Next, we will be covering the problems on Poisson distribution. So students, now let us see some problems based on Poisson distribution. Well, I have given a simple problem of 1 or 2 marks which usually comes for the exams, as well as another problem which uses the probability mass function. Now, first question given here is, if a random variable x follows Poisson distribution such as p of x is equal to 1 is equal to p of x is equal to 2, we have to find mean, standard deviation, as well as the first probability term. So students, let us now analyze and understand how to do this particular sum. They have given us that it follows Poisson distribution. That means we know one thing clearly, that this is a sum of Poisson distribution. That means x follows Poisson distribution, and Poisson distribution has only one parameter, which is lambda, and we do not know what it is, so I will write it lambda itself. Next, students, they have given p of x is equal to p of x is equal to. That means they are clearly stating that p of x, in the sense it is, what is it? It is the probability mass function. So we will write the probability mass function for a Poisson variate. PMF is nothing but p of x is equal to e to the power minus lambda into lambda to the power x by x factorial, and this follows x is equal to 0, 1, 2 up to n. Is it up to n? It is up to infinity. So understand, this is Poisson distribution, and Poisson distribution, the range goes up to infinity. Now, they have given us that p of, so this is the first question that we are doing. A, we have to find out the mean, for which they have given p of x is equal to 1 equals to p of x is equal to 2. What do we mean by this? Very simple. It means the probability when x is equal to 1 is the same when the probability of x is equal to 2. Let us write the probability mass function now. It is e to the power minus lambda, definitely we do not know what is lambda here, into lambda to the power x. What is the value of x now? It is 1 divided by 1 factorial equals to e power minus lambda into lambda to the power. How much is x now? 2 divided by 2 factorial. Observe it carefully, students, now. E to the power minus lambda, e to the power minus lambda gets cancelled. Here lambda power 1 and lambda power 1 gets cancelled. So only 1 lambda remains here. So final answer will be in this way. Here numerator nothing remains. So it is 1 divided by 1 factorial is 1 itself, is equal to here only lambda remains divided by 2 factorial is a 2 into 1. Next step, cross multiply, we get 2 ones are 2 is equal to lambda. So students, lambda is equal to 2 and that is what is called as mean. We have found out the first one, mean is equal to lambda is equal to 2. Second, what we have to find out? They have given find out standard deviation. So students, recall and tell me what is the formula for standard deviation of a Poisson distribution? It is square root lambda, which is nothing but square root of, what is lambda given to us? 2. So this is the answer for the second question, that is find standard deviation. And the final question, they have given us find the first probability term. Now whenever probability term is asked, students, it is probability mass function. Write the probability mass function formula. P of x is equal to e power minus lambda, lambda power x by x factorial follows x is equal to 0, 1 up to infinity. Substitute and find the answer. P of, we have to find the first probability term, and the first probability term, what is it? It is P of 0 is equal to e power minus, we know what is the value of lambda now. How much is it? It is 2. So e power minus 2 into 2 to the power 0, because lambda is 2 and 2 to the power x is nothing but 0, divided by 0 factorial. Students, remember 2 to the power 0 is 1, 0 factorial is always 1. So what remains is e power minus 2. Look into your Poisson distribution tables of statistics, students. Find out what is the value of e power minus 2. The value of e power minus 2 according to the statistical tables in Poisson distribution should be 0.1353, and that is the answer for the C question. Find the first probability term. With this, we wind up the first question. Let us look into the second question as well as the answer now. So now the second question. In a textbook, on an average 0.3 mistakes. If there are 500 pages in that textbook, in how many pages there will be? A, 3 mistakes, B, at the most 2 mistakes. Let us see the second condition later. Let us concentrate on the first condition now. A, 3 mistakes. Even before we go there, students, let us analyze the data and what is given to us. They have given in a textbook, on an average, there are 0.3 mistakes. On an average and mistakes. Average as well as mistakes. Students, we have understood that Poisson distribution is a distribution which usually speaks about more of failure, less of success. That means more of failure, more of defectives, more of mistakes, more of accidents. If all this is there, that means it is Poisson distribution. So they have clearly given to us here it is mistakes, and average is given, average in the sense mean, and mean in a Poisson distribution means lambda. So lambda is given to me as 0.3. What else is given? If there are 500 pages, that means number of pages, capital N is given to us as 500. Any other data that is given to us? No, they have not given any other data, but we know average is 0.3. That means we can conclude X follows Poisson distribution with the parameter 0.3. Along with this, we can write the probability mass function, students. Next step, PMF is P of X is equal to e to the power minus lambda, lambda to the power x by x factorial, where x is equal to 0, 1, 2 up to infinity. So students, let us come back to the first part of the question, which says 3 mistakes. So probability of 3 mistakes, very specifically given. Probability of 3 mistakes. So P of X is equal to 3. We don't have any confusions here. P of X is equal to 3. So P of X formula, e to the power minus lambda. What is lambda now? 0.3 into lambda to the power x, that is 0.3 to the power x is 3 divided by 3 factorial, or x factorial, and x is 3, that is 3 factorial. So students, look into your Poisson distribution tables and tell me the value for e to the power minus 0.3. You need to be very quick in searching the values here. So e to the power minus 0.3, what is it? It is 0.7408 into 0.3 to the power 3. 0.3 into 0.3 into 0.3. How much is it? 0.027 divided by 3 factorial. 3 into 2 into 1, which is, okay, I will write it in details so that you do not get confused. Multiply this, students, and divide it by 3 into 2 into 1, which is 6. You should get the divided value as 0.0033. So students, remember, this is not the conclusion now. They have asked us if there are 500 pages. So we have to do, therefore, probability of 3 mistakes in 500 pages is, what we have to do is n into P of X is equal to 3. How many pages are there? 500 pages into, what is the probability of mistakes we got? 0.0033, and multiply the, students. Check out what is the answer. You should get 1.65. Once you get this, do not forget it to approximate. So approximation, and the nearest value will be 2. That means there are on an average 2 mistakes per page if there are 500 pages in a textbook. So we have finished the first one, A, that is 3 mistakes. Now let us see how many of you all can solve B, at the most 2 mistakes. So now students, don't get confused here. This is the second question. In a textbook, on an average, we did this sum entirely and we finished the first part, that is 3 mistakes. Now we will look into the second part of the equation, B, at the most 2 mistakes. If you look into the board here, the second question's answer, lambda is equal to 0.3, n is equal to 500 pages, x follows Poisson distribution where lambda is 0.3, probability mass function is equal to e power minus lambda into lambda to the power x by x factorial, and x follows, or the range is 0, 1 up to infinity. Up to here we saw in the previous part while solving A as well. But now students, kindly note the change here. We are working out the second part of the question, which is B, at the most 2 mistakes. Now we are doing the second part of the question, which says at the most 2 mistakes. So students, at the most 2 mistakes in the sense, a person can make maximum 2 mistakes, not more than that. That is, either he will make 0 mistakes, or that is plus he will make 1 mistake, or he will make 2 mistakes, that is p of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2. Rather than finding out 3 times, students, which will definitely waste a little bit of time, we can do the other way around, that is 1 minus probability of 3 mistakes. So if it's 3 and more than 3, what happens is, here they have asked us at the most 2 mistakes. So we will do the other way, 1 minus 3 mistakes. So that is nothing but 1 minus, what is the probability of 3 mistakes? We worked out in the first category, A, 3 mistakes, and if you check your books and if you have worked out along, you will see that probability of 3 mistakes, we got the answer as 0.0033. So 1 minus 0.0033 will give us 0.9967. This is not the final answer. They have told us for 500 pages. So for 500 pages, it will be the probability into the number of pages 500. You will get 498.35, which is approximately, students, 498. Students, do not lose confidence, be it binomial distribution, be it Poisson distribution. The sums are very simple. Apply it carefully. Definitely you will get them all right.